LED. LED on PCM mode, that is on this page. And the next page is LED on board mode. Okay, depending upon the mode, we may have a little different code or a little different wiring. Remember that here we need to do wiring, scripting, and running. Okay, wiring, scripting, there's nothing but coding, and running, therefore we're sensing the data. So wiring, scripting, running, or wiring, coding, sensing. Anyway, those three steps needs to be taken very carefully. Okay. So we have code here for this LED on PCM mode. And similarly, we have a code here for LED board mode. Made as a sample. So there are four colored LEDs, right? Each LED has some of the wires, okay, connected in this breadboard. This is so-called breadboard. What the breadboard can do is, this is a breadboard. So it has line horizontally, and then let's say this is a blue lines horizontally, and red is a hot line, and blue is a ground. So we have those two lines. Horizontally, they are connected. Same thing here on the bottom. And then this as a whole is two parts, bottom and upper. And all other pins are vertically connected. Okay. If you have a jumper cable into one of those, I have jumper cables here. Let me find out one jumper cable. Okay, this is a good example of a jumper cable. This is jumper cables. One end, there's a male, and the other end, the female. Some types of jumper cables, maybe stitched together as a bundle, you can buy it. And there are many different types available. So if we choose one of those, then because this is female, this is a male, you can plug this funny connection. But anyway, this is a circle, unplug. So if you plug in one of these, then all these lines, vertical lines, they are all connected. So rather than weld something, you can simply, once you connected this, and another pins from, for example, LED, you may be able to see they are connected. For example, I have an LED here. As I said, LED has, this is a red color LED. And then, not sure you can see it. So two legs found, one longer and one shorter. Okay. Longer positive, shorter negative. Okay. So positive in this case, you need to load. You need to give a hot. and short, then that is the ground. So what I did here, okay, so we have here, this is I would say, uh, back to our, if you see your, then shorter lines goes to the ground, and the longer line goes to here. See the page right now 19, then let's start with the BCM mode first. Then BCM, the GPIO number 21, that is connected to the long leg. Short leg goes to the ground. And in the middle of that short leg, we can put there some of the resistance. Okay, this resistance to protect any of power surge. But LED is normally it's not that sensitive. But when it comes to sensitive sensors, then you need to be very careful to get some of the resistance. So I put as an example resistance. Someone may be confused that, oh, how can I buy all of those? If you go to Amazon, then there is a Raspberry Pi the kit that is possible. Otherwise, you need to buy all each separately. Then you may have so many of those unnecessarily. Okay, so if you have this, then you have LED, and I'm not sure. So we have LED and two jumper cables. So this goes to, if you see here, these vertical lines connected to the resistance, and then go to plugged in. This resistance is in this way. This is a resistance. Resistance, there is no no signs, right? So it doesn't matter which one's plugged where. It's not plus minus things. So you only the connection. So one leg goes to the same horizontal line of this this. So connect that anywhere, but you have to make sure that once it is connected to that vertical lines, into the same vertical line, into the same vertical lines, you need to have, say this is a short leg goes to that, and the other one somewhere there is a long line. This is a long and this is a short. From the long, then you need to have another pin vertically the same line and get that pin out. So we have a pin out here. Let's say there's a purple. Okay, purple goes to the power. No, goes to that pin that we saw, the PCM, one of the PCM, okay? The other one there. This goes to the ground. So before we set up this on the Raspberry Pi, the breadboard, leave it here, the breadboard, and then we need to do code. So I am, again, you can see, I want to work on this Raspberry Pi, that monitor, but monitor is not really clear. So what I am trying to do instead, back to the screen share, and now that B and C screens here, only B and C. So I think you can see my keystroke on the terminal, right? So you need to report to the code clearly. How can you code? There are many ways that you can do, but I wanted to, where are we right now? If you type PWD stands for print work directory, working directory, whatever that is, right? So where are you right now? That's what it is. So if I click that, then I am under home. So home is top directory, top folder. And under there is a PI. PI is my login ID. So I want to create another subdirectory. So mkdir. Mkdir means mk make directory. mk make dir directory. I want us to, for example, LED sensors. Okay, say sensor singular. Enter, and I want to see the list of the files in the current the folder current directory, which is under PI. Then I can see that many. You may be able to see sensor directory. Here are the sensor, right? This is a sensor. This is now created. Those who do not know Linux, then you can learn it. You can, as you work, you may be able to learn. Okay, so ls minus l. This is another option. ls stands for list. So you want to see the list of the content. ls minus l. There's a space in between. Minus, therefore, there is an option. So ls minus l. So you want to see the longer list. You want to see the list in the long form. Right now here with no option, this is a short forms. Short form means you cannot see anything but only the name, right? If you do this ls space minus l, then you have a longer form. So for example, if it is a sensor, pi is actually the root user in this case. So it's a sensor. And by the way, there is an access control, as you can see here. So this code tells us the first character, hey, this is a directory. It's not a file. And then next to three characters tells us what can I do? I can do read, write, execute. So RWX. So three actions are granted to this guy. Okay, this is owner access control. And next to three, all dash X. Dash means is not granted. Which one's not granted? Write action is not granted to me. That's not to me. First three characters for me, and next three characters for the group where I am. What is the group right now? This is the group. But in this case, for simplicity, myself in the group PI where I am, I may be the only one. Okay, so if you, because you are the owner and also in the same group, this is your privileges. So that you have read, write, and X. And the second one is group. Let's say you're not in PI, but you are in another group, for example, faculty or student. So you may be able to give different privileges to student group, different privileges to faculty group, and things like that. And then last three digits tells us the privileges assigned to the public. Whoever in this system, in this Raspberry Pi, can do. So they can read sensor directory, but they cannot write, but they can execute it. What type of execute available in this directory? Usually, if it is a directory or folder, then the type of execution is change directory. So CD for change directory. So I can open that directory. That means change directory. I can change my directory to that subdirectory. So CD sensor. So I can go inside that directory. So when I print the working directory, then I know I am now home / home / pi / sensor. Previously, I am in the / home and / pi. Now on the sensor, right? If you want to list in that directory, then you cannot see any, right? But there is another thing that you can see. I want to see all for A for all. What that means is that there may be some files or some symbols are hidden. I want to see it. That's also adopted in Windows systems these days, right? So some files may be hidden from regular users, but those who know can see it. These days, a lot of those things are available, right? App data, for example, that a typical the directory that you cannot see from your the Windows browser on Windows. That was available from the beginning of this Linux history. Linux history is not really long. It's almost 30 years long, as opposed to Unix history, closer to, I think, 70 years, 80 years, almost a century. But anyway, ls-a, then you can see some more. If you want to see ls-aal, then there is a long form, but for all the files, including all the hidden files. I want to list them, then you can see clearly. Single dot and double dot. Single dot, that is directory, and double dot, that is also directory. What that means here is that single dot means that is myself. That is me. Whenever you want to do something here, let's say you have some application files here. Depending upon your setting in Linux, it doesn't look for my current directory, but it goes to some of the bin directories. That is the file system organization. File systems are structured in that way. All the files that you can see here is not here on my directory, but this is a server, right? So let's say we have 100 users, then each user needs to execute some of the files. Each user doesn't need to install separately, but system administrator can install one application. That application should be executed by the users. So it should be somewhere, right? But if you want to execute, so usually it goes to that pre-designated directory, not my local directory, not my current directory. But if you want to if you want to execute explicitly some of the program on this current directory, then you need to say dot and slash dot is my current directory. So everything is divided by slash, right? So you need to type whatever the file. So my current app executable, something like that. But it is not, of course, it's not going to work because there is no such applications here, right? But anyway, that is the case. Python, for example, we might have multiple Python programs. Let's see what type of Python runs. Oh, Python 3.92, oh, which is so good. Let's quit that Python. So where that Python program is located. If you say where is Python star, then you can see where is Python, then we may be able to see Python is available /user /bin /python and then /user /bin Python 3.9 and so many others, right? So 3.9 is currently the one available, right? If you want to download the Python 3.10, that is also possible, right? So how can you do that? You need to do sudo apt get install Python 3.10. Then it goes to the network and find out Python 3.10 and bring it down and install. What does that means is that this installation of the application is only so my BNC maybe try to disconnect because all right. So so apt means I think there's an advanced package tool maybe. So that is the only the administrators tools to manage the packages in advanced levels. That is apt. Dash get you may or may not. Currently, you may see only apt find or apt dash get. This is the program that you need to whenever you do something advanced package management, then you need to start with this, and there is an option. Hey, one of the management is installation. So I want to install. So install what? Python 3.10. That's what it is. Okay. Let's try to get that. I mean, those who wants to see that. Sometimes it takes a little longer, but You don't need to install this. You can do that. Yeah. Okay, it is done. So I installed it, right? So when I oops, unable to fetch some. Let's see. Where is Python? It's not installed. Probably not installed. Yeah. If you see USL in Python, there goes a Python 3. So Python star. Then we can see this is Python 3, Python 3 dot. Well, Python 3.10 is not installed. Somewhere here, unable to fail. Oh, a lot of failures. I think connection is another issue. So you can do that. Well, in fact, in order to do that, you have to do sudo apt get update and upgrade. Update means you want to change it, you want to update the files that indicates the package repositories that's available all around the world. So when you upgrade one of the packages on your Raspberry Pi, then it goes to that repositories, and then download and upgrade. So even if this is the same Linux, the Raspberry Unix is not the same as, for example, OS X Linux. It's not the same as another Ubuntu Linux or Kali Linux. All different. So it has different the repository list. So update is to update that repository list after you update. And then update is simple. We can update very quickly. And then we need to upgrade. So in order to do this upgrade, usually it takes also a longer time. I'm going to skip this. Rather, I'm going to use the old version, 3.9. 3.9 is still okay. 3.3, 4, 5 are all okay. 3.10 only, there's a recent version. And by the way, there is a 3.11 beta version is also available. So we're not going to use that. You can upgrade this to 3.10 later. And if you want to run 3.10, some of the symbolic link needs to be done here. This Python, when you click Python, then it goes to Python. Python equals to Python 3. Then when it comes to Python 3, it goes to Python 3.9. Actually, this program is running. Okay, so if you have Python 3.10 in addition to this, then instead of 3.9, you need to put here 3.10. When it comes to that installation, done here, but not yet done. Okay, so Python 3. So we are ready to run a Python 3. We need to do now code, the file editing, right? We need to make a file. Currently nothing, right? We need to make a file. How can you make a file? The editor is available, right? Editor. What kind of editor is available on Linux? The default editor, default means wherever you have Linux or Linux distributions, you still have that editor available. Some other editors are a little more advanced and higher level of editor. So usually they may or may not be available. But this editor is always available, which is a BI mode. So BI comes from visual. What that is, the visual editor was invented in the early 1980s. Before we have a BI editor, that is simply editor, ED, editor. That's the line editor. That line editor is very similar to the punch card. Some of you may have heard that punch card was used in 1970s, right? Very long time ago, before we have personal computers available. And so exactly the same as punch card. The punch card is one card has one line of statement. There's one punch card. So if you have, for example, 100 lines of code, then you need to have 100 cards in sequence. So if you swap some of the cards accidentally, mistakenly, then your program is not going to run. Okay, that card needs to be saved very carefully, so that the next time if you want to run the same program, then you need to take that punch card to the operator. Then the computer center has an operator. So operator stack that punch card into that input device, and then the input device read each page per statements. So it is like a code editing. So that each line of each card is converted to electronically. So that is edit, ED. And after that, visual editor. So doesn't matter how many lines, we can make a sequence of lines in our code editor. So we can do that. So at that time, it was really, really sensational, right? Right. There are a lot of stories, but I'm not going to say that. But yeah, I've never used punch card. I've never used ED, but I'm still using BI. BI is really, really good. BI, if you want to know BI, then you need to read this manual, man BI. Then so a lot of the options and the keys that you can use, because we do not use the mouse. We simply use the same keyboard, one time to edit, another time to control, like cursor movement. Right now we have a mouse, so mouse can do. But before we have a mouse, then what we need to do? We still have only one keyboard. So there is a toggle mode, which means hit some key, then you can one time edit, hit the same key, then it goes to the control. So use a key to control up arrow, down arrow, left to right, or copy and paste, delete, and all those things. That can be known from this manual, VI manual. If we want to, so I'm going to use VI. So for my future use, I want to make the manual available all the time. Then if you want to do that, then you need to, I want to save that manual. You want to save that manual under this sensor directory or top directory of your home. I want to make it my home. If you want to go back home, by the way, when you do this, I forgot to explain this, right? So dot is myself. What is dot dot? So if I want to do cd dot dot, I don't need, because my parent is always one. Why should I specify which parent, right? Because it's tree structures. If it is a tree structure, then I have only one parent. Although I have many uh, children, right? One parent. So from any of my children wants to come to me, then they always say, "Oh, my parent." They don't say which parent, right? But when I say my children, or if I want to point to a specific child, then I need to say which child. So when I change directory from top to bottom, then I need to specify which ones. However, from bottom to top, I will always say cd dot dot, cd dot dot. Then I go back up one level, back up one level, back up one level. When I do this, PWD, now I am in PI. When I do cd dot dot, I am in home. When I do cd dot dot, all the way up, right? So all the way up, there are that many system top level directories. So I may move the directory from the line of my uh, family all the way up. And then I go to another line, right? For example, CD, USR, PWD. Then I'm in another line from the top. And let's see what I have there. Oh, there are many bin directory. So if I do bin directory, bin for binary directory, then where I am in /usr/bin directory, right? And then I have so many, right there. I play with somewhere, okay? I may visit to my cousin or second cousin, third cousin, fourth cousins, all different different lines of my family from Adam and Eve and all. Wherever I am, I may go in another line deeper and deeper. How can I come back? Come back home, my home. Should I come back again? CD dot dot, CD dot dot, CD dot dot, all the way up to the slash top. And then I need to choose CD home and CD PI. That should work fine. Would there be another way, much simpler? If we do CD with no target, no data, just simply CD, hit enter, come back home. How nice, right? It's CD. Change the directory with no data, then come back to me. If you go to directly CD, USR, and bin, same way, in the same place where I was, right? CD slash. If you want to jump to that specific my cousin's line, then you need to, rather than dot dot, you can simply CD. You can specify from top /USR. Don't forget slash first. Slash means top. /USR/bin. Then it'll be there. And those things exactly can be seen when I do this, right? There. Okay. So now I know how can I go back to my home directory. Even further, is there any way that I can go back, not only my home directory, but subdirectory of mine, if I know it, like this case, I know sensor directory that I created, which is mine, which is the top level of my home directory within my home directory. So I know where it is. Can I directly go back to jump back to that specific my subdirectories? I know how I can come back my home directory by cd, hit enter, and then tilde slash sensor. Then it'll go back to my home directory. Tilde is my home. Wherever, if I want to see tilde, then that is me. So tilde, when I do ls, then that is current list of current content. When I do ls and tilde, let's see, tilde was tilde slash tilde fine. Tilde, then there's my home directory, right? Where there is a sensor. So tilde, this is it's another handy. So tilde, ls tilde slash sensor, then jump back to one of my subdirectories. pwd, cd tilde sensor, then come back to my sensor directory. Anyway, so in this way, we can travel back and forth somewhere in my file systems. Anyway, I cannot be orphanage. So handy. Always I can directly go back home, right? Okay, here now. Oh, by the way, I want to make a manual, right? If you want to do manual BI to my file, my own file, then man BI, then it'll be saved as man BI. We know this gives you interactive manual, right? There is a greater than sign. So whatever the output of this will be saved into this file. Man BI, hit enter, ls -l. Now I have man BI, right? Man BI, I have a sensor directory. This man BI is, you can read it, man BI at any time, like this, okay? If you want to search within that man BI, then we need to use, rather than more, you can use less. And then if you say move, what did I say? Oh, more. Then if you go further, back, further, that is possible if we do less. That is more or less. More, you want to see the long file screen by screen. That is more. Less, same as more. So you can see scroll, page by screen. But in less, you can reverse, go back and forth, back and forth. More, only one direction. So many Linux commands. I want you to practice. Okay. Now go back to sensors. We need to finish up our business. BI, let's say led1.py. Because this is Python, led1. I have one LED. Enter. Right now, when this editor is open, by the first mode is control mode. whatever you type here, that is a control. It's not going to be typed. But at very first time that you need to do is when you open this, either you need to make I for insert or O for open, doesn't matter. So let me put I. And once you say I, then after that you can type. Okay. Backspace works. Now I want to do that code. So import time, import rpi.gpio as gpio, and then gpio dot set warning false. I do not want any warning. gpio dot set mode. I want to say gpio dot bcm, and then gpio dot setup, and then remember that BCM in BCM mode, the last, oh, you don't see it. The last, the pin is 21 because that starts in, well, anyway, 40 pins, but it is labeled to 21 in BCM mode. So I want to use the BCM 21 and gpio.out. If you want to switch mode on this BI mode from typing to control, then always hit escape button. Escape, one time escape button, then you can control, and then hit escape button, then you can type. So I hit escape button, and then move mouse up is K, move up, and if you want to do DD, then delete a line. I want to delete time at this point, so we don't use it for simple. So DD, it is deleted, and move the cursor up and down. K and J. J goes down, K goes up, and L goes to right, and H goes to left. So on your right finger, if it is positioned properly, so on your finger is positioned K, J, H, and L in the middle. But anyway, if you want to continue to work from the end of this line, then you need to do here wherever you are on that line. If you want to continue to add on that line, then you need to have uppercase A for append. So Shift A, then your cursor is to the end. Of course, it is from there it works, right? So hit enter to the next. I want to do, okay, GPIO dot output dot 21, that pin number, and I would say true, and then I do escape button and all the way up. I probably need time, and there, if I want to insert, I press I and then hit enter, the next line. Under the escape button, move cursor up by pressing K, and then type I, still control. If I do I, then I can type there. So import time, escape, and come back all the way down here. And what I want to do is I want to, for example, time.sleep. I want to sleep, for example, 5. And then GPIO dot output again. And then same 21 pin, at this time false. True means light on, false, light off. Okay. So if I want to do this, and then you can do another time, 5, and then I can copy 4 lines. Copy 4 lines is not really available. What I can do is I want to delete 4 lines. So number 4 and DD. And then I want to paste uppercase P and one more P. So what happens is that this goes up. Here. Okay. So in this way, I set up. I want to change this. This is not send warning. I just set warning. So if I want to replace N to T, then replace, that is all, and T, then it can be replaced. Okay, so I want to save this. Hit escape button, and saving is a shift ZZ, uppercase Z, 2 times, ZZ. Then it is saved. And when I do this, okay. So here, as you can see, this the layout on the textbook. Here, the ground. Okay, ground needs to go to top 3rd pin from right. So I plug that on the right out. So 2 vertical lines on this pin. If you hold this up, let's see if you can see. Oh yeah, you can see it. And then this purple line, I want to put the bottom right end. Okay. So that is wired. So I have wired, and I have a code there. I'm going to place this here so you may be able to see if the light's on. And then I want to run that Python and LED1.py. If you see that code, let me read that code first. More LED1.py. So there is a code. Python LED1.py. I want to run. Okay, that is what it is right now. So if I hit enter, then you may be able to see this is a breadboard, and this is LED here. So first the lights on this code, GPIO out 21, pin number 21 of this Raspberry Pi. That should on true, false, true, false, true, false. On and 5 microsecond 5 microsecond and off, and another one and off. So 2 times on will be done, right? So yeah, so hit enter. On is 5 minutes. Off. Oh, there is a coding errors. Typo. So what is that I need to do? Where am I right now? This is here. Okay, screen share. Back here. And share. Here right now, I need to go back to that file again. So BI and LED 1.py. Sleep. Problem is this sloop. I want to do change that. XX insert EE, hit escape and shift ZZ, and I want to do Python LED once more. So stop sharing, and you can see the monitor here. Watch this. Lights 2 times on, right? On 5 seconds, off 5 seconds, on. So it'll be turned on for 5 seconds and off for 5 seconds and turn back on 5 seconds also. I want to hit enter so that Python code will run. Watch that LED. Off 5 seconds and it'll back on again and off. Okay, and then my code is done, right? So the code ended. Is there any possible that I need to do continually? Yes, we can do. So let's do a little bit of the extension of the code. You can see here. So again, I want to go back to VI editor. Like that we see on the textbook, I want to put the while loop. Okay. So while true and colon. So it'll be on all the time. Oops. GPIO and then sleep again. Okay. 5 minutes waits, that's too long, so I want to change it to 1 minute only. 1 second, not 1 minute, I'm sorry. 1 second on and 1 second off. Okay, so that'll be on and off continually. I want to make this a 2 second on and 1 second off. How about that? Okay, this is while true, which means always, until I turn this off and do that. And then I will run that program. So program, now hit enter, it will run continually. So I want to show it to you, the camera. 2 seconds on, 1 second off. How long? Forever. According to my code, I didn't put any terminate conditions. It continues, right? It's like a ball drop. Okay, I think this is it for a little bit of introductions of Linux um, and the first small project using LED on and off. Basically, knowing some of the characteristics of LED, the sensor device, then there are 3 steps. You need to do properly wire, and then script. You need to code, and then finally run. Okay.